Hey, welcome to this introductory video on how to read solubility curves. So it's going to be a combination of some video footage that I found off of YouTube from another site and some of my own created video. Hope you like it. And certainly write down questions. Now's a really good time to take out your notebook handout that I gave you and some other paper to be able to take some notes during the course of this video.
We have learned about the solubility rules in a different lesson. These rules help us predict whether or not a salt is soluble in water. For salts that are soluble in water, some are more soluble than others at a given temperature. In this lesson, we will learn about solubility curves, which is a graphical representation of the solubility of a certain salt over a temperature range. If we were to compare copper 2 sulfate and potassium sulfate, we will find that one is bright blue and the other is white. If we tried to dissolve them in water of equal temperature, we will find that copper 2 sulfate is a lot more soluble than potassium sulfate. In other words, copper 2 sulfate has a higher solubility in water. This is actually a physical property of a substance, much like a substance melting point and boiling point. The solubility of a salt is usually measured as grams of salt per, let's say, 100 grams of water. Here is a challenge for you. Do you think solubility increases or decreases with temperature? Pause, think, and continue when you have an answer. The answer is that solubility usually increases with increasing temperature. So, if we dissolved copper 2 sulfate and potassium sulfate in hotter water, we will find that more of each salt is able to dissolve. This observation is only applicable to a solid dissolving in a liquid. We can measure how much of a given salt can dissolve in 100 grams of water at a certain temperature. We can plot solubility as a function of temperature to give a solubility curve.
So in this portion, I'm just going to show you how to read a little bit more detail about reading a solubility curve. And so it's really important that a couple of things that you notice is pay attention to the y-axis. On this axis, you're going to be able to determine that you have a saturated solution, okay, that contains 100 grams or 100 milliliters of water. And then on the x-axis down here, you notice that it's showing you temperature in degrees Celsius. So it's really important as you're reading these curves that you're paying attention to the y-axis, which says solubility, and the x-axis here, which has temperature. Now, one of the things that's very important is if I'm looking at every point along this curve here, this is a particular graph of sodium acetate and its solubility at different temperatures. Every single point along that graph, it's a saturated solution. And it's really important that we remember that it represents saturated solution. Okay, so you want to go ahead and type that into that section there. Second of all, sometimes we might have situations where we actually are trying to dissolve less. So we might be here in the point of this curve, we might at say, 80 degrees Celsius, and we might be trying to dissolve, about 90 grams. But that's less. Because that's less, that means I have an unsaturated solution at whatever that particular temperature is. Now, we will deal with some situations where we are trying to dissolve more than what can dissolve or the saturation point is. So for example, if we go to sodium acetate and it's 75 degrees Celsius, let's say we try to dissolve 150 grams of sodium acetate. That's up here and it's above my saturation point. Now, it can create something called a supersaturated solution, but we're not really going to focus on that. Instead, we're going to be dealing with sort of this case down here, which is if we have that, if it's above the line, it's probably not going to all dissolve, okay? The reason is because it's saturated. So the most that it can get is at that line. It can't get above that line. And so now we're trying to figure out how much is undissolved. Well, we can do that by using a fairly simple equation. In this equation, we're going to determine the mass at the bottom of our solution by taking the total mass of solute that we've added. In this case, it would have been 150 grams. And then we subtract that from the mass that at that temperature can actually dissolve. So in this case, we'd read up our graph and we'd look and we'd see that, okay, it looks to me like about 100 and say maybe 20 grams can actually dissolve. So what we would do then in that case is we would take 150 grams minus 120 grams, and that would give us 30 grams of mass that's undissolved at the bottom. Okay. You're also going to see in this next video that a trend is true, is that solutes that curves and move upward increase with temperature are typically talking about solids in water. That's the trend that we see in these particular samples. We'll talk maybe a little bit later about things that decrease as temperature increases. But for right now, we're just going to focus on solids and water. So what's going on when we have a saturated solution, say 100 grams or 100 milliliters of sodium acetate at 100 degrees Celsius? What happens when it cools? Well, when it cools and goes down this curve, you're going to end up getting a saturated solution that ends up becoming less saturated. And so what will happen is the precipitate will form as the solubility decreases. Solute will undissolve or crystallize out of solution. We find the mass of this precipitate by simply using a simple equation here. We can find the mass of this precipitate by using a fairly simple equation. It's straightforward. And essentially, we find the mass of the precipitate by taking the mass of the dissolved solute at a higher temperature and subtract it by the mass of the dissolved solid at a lower temperature. So we're going to be working on some of these problems in class, and we'll go over a little bit more carefully about how to do that. The very first thing that we need to do, though, is we actually need to just simply read the graph. Okay, and so you're going to watch this next video, which will show you essentially and basically how to read the graph.
Here are solubility curves for copper 2 sulfate and potassium sulfate. We can see that for all temperatures, copper 2 sulfate is more soluble than potassium sulfate. From a solubility curve, it is also possible to find solubility at a certain temperature. Let's say we wanted to find the solubility of copper 2 sulfate at 90 degrees Celsius. Take a ruler and draw a vertical line starting at the x-axis at 90 degrees Celsius until it reaches the curve. Then, draw a horizontal line from the point on the curve until it reaches the y-axis. At 90 degrees Celsius, approximately 68 grams of copper 2 sulfate is soluble in 100 grams of water. To compare, at the same temperature, only 24 grams of potassium sulfate would be soluble in water. Using the provided graph, try to find the solubility of potassium sulfate at 60 degrees Celsius. Pause, try, and continue when ready. If your answer is around 18 grams of potassium sulfate per 100 grams of water, then you would be correct. When a maximum amount of a certain salt is fully dissolved, the resulting solution is known as a saturated solution. In a saturated solution, no more solute is able to dissolve. If we took this saturated solution and let it cool, it would become a supersaturated solution. This means that there is more solute than the maximum amount able to dissolve. When this happens, some of the solute may crystallize or come out of solution.